Welcome to the VHDL session 2. Today's topic is architecture. In this topic, we are going to discuss about structural and the behavior model. We will take 1-bit adder and 2-bit adder as an examples for this session. Behavior model based on 1-bit adder. Initially, you have to identify the inputs and outputs of 1-bit adder and write the truth table and relate the inputs and output either sum of product or product of sum format. This relationship can be directly written in architecture. This will clearly indicate how the system behaves. Thus we call as behavior model, as shown through the initial 1-bit adder design program. Write the entity and write the architecture. Inside the architecture, define the input-output relationship where either sum of product or product of sum. Then compile the code, write the test bench and observe the output for the given input. Once it's done, we can move to the second architecture, that is structural design. We will check 2-bit adder. As we discussed earlier, the procedure can be repeated for 2-bit adder. However, the operation of 2-bit adder doesn't vary from 1-bit adder except one or two minor changes. Therefore, 1-bit adder code can be used as a component in 2-bit adder code. This is called as a component declaration and port mapping, as shown in the second part of the program in this video. Here, the existing code is used as a component of a top layer. This follows like a hierarchical design, thus we call as structural architecture. So the structural architecture design process flows like: design the top level model entity, then move to the architecture, define your component of 1-bit adder. The easiest way to write the component is go to the 1-bit adder VHDL code and copy the entity and move it directly inside the 2-bit component session. Then complete the component declaration. Then go inside the begin. Now you can do the port mapping. What is a port mapping? Is that you have to send the input to the 1-bit adder component. So whatever the input that you define for your 2-bit component, you have to pass that information to the 1-bit component. So when you do that 1-bit adder will give the results. That results can be again mapped to the 2-bit adder output. So this process clearly indicates that we are using the existing 1-bit adder component code and we are building the 2-bit adder based on it. So this is we call as a structural design. Thank you for watching.